Hi, everyone, again. It's 3 o'clock and we're on our third presentation. First of all, I just want to say this team gets the award for Best Team Spirit. I love your t-shirts, guys. They come from us, or they are with us from the University of North Texas. We have Dr. Deepak Privan with the students Anna Robinson and Jared Costello. Their advisor is CIRI's Senior Research Program Manager, Jose Medina Cruz. And take it away, guys.
All right. So thanks for this opportunity, and thanks everybody for coming to this discussion. Our topic is evaluating ontologies for cybersecurity workforce development application. So we'll give some context, discuss the problem, also discuss a tool that CIRI has developed and continues to develop. Then we'll talk a little bit about frameworks and standards, then methods, our results, etc. So as everybody probably recognizes here, that cybersecurity is a complex discipline. And it is complex because it is not just a single discipline, it is an amalgam of multiple disciplines like computer science, psychology, social science, project management, law, just to name a few. So to hire cybersecurity individuals, many different disciplines are involved, and not every subject matter expert in cybersecurity has to have knowledge of all the areas, but they have to have specific knowledge. Some may have more generalist versus specialist, and so the challenge of hiring is large just from that perspective. So according to one statistics, in US today, there are about 500,000 open cybersecurity jobs. And now if you compare this with how many cybersecurity people we have, so roughly the estimate is there are about 1 million practitioners. Another report says that by 2021, that is now we are living through it, there are about 3.5 million unfilled jobs. So these numbers are staggering. So obviously it is a big challenge. And this challenge is and we saw a discussion about this in Dr. Kim's presentation, that the challenge is for the entire workforce, right? The entire supply chain. So starting from the training and teaching to recruiting, hiring, and executing projects. And we'll discuss those are some of the aspects here. According to the NICE framework, which is National Initiative for Cybersecurity Education, it can be difficult to clearly describe the work. And we heard about it enough, so we'll not elaborate on that. But this is the key factor. It's an emerging discipline, it is ever-changing discipline, and we need to have a common, well-understood way of describing what is work. So what is the problem? So the problem, on one hand, we have various controls. So controls are, mechanisms, procedure, organizational processes that allow an organization to ensure that the various cybersecurity practices are being followed. So that is what a control is. So there is a standard from NIST. It's called 853, and they describe number of controls in number of different disciplines. So on one hand, we have those controls. On the other hand, on the NICE framework, which describes the cybersecurity work as a task, knowledge, and skill statements. There used to be ability statements also, but in the recent revision, the ability statements are not included. Here, on one side, we have descriptions of various tasks required, various knowledge and skills required. And on the other hand, we have controls needed from the organization perspective. This is at a more initially focused from the people perspective. This is more focused on activity perspective. So how do we match this? So we'll see a concrete example. One thing I would say just as an FYI is that in the NICE framework, even though the picture this describes the task, knowledge, skill, this sort of bundling is not present directly, but it is, this each items are sort of separate, and as we will discuss our activity, we'll talk about that. So the problem, here is an example. So on 853, control description would be a long description. I have given just a synopsis here. So it will talk about this specific control, let's say account management. What does account management mean? It means you identify and select the following types of information systems, accounts to support organizational mission and business function, and it goes in a little more detail, right? On the other hand, if you look at the TKS, the task, knowledge, skill statements, they would look like this, something like this. So the task would talk about identify and prioritize essential system functions or subsystems required to support essential capabilities or business functions, and so on and so forth. So the job is to find out what control requires support from which task, knowledge, or skill. That's the matching situation that we need to work on. So one of the tools that CIRI has developed, it's an existing tool that exists today. It is meant for businesses, large and small, to map the knowledge, skills, abilities required to perform cybersecurity tasks. So in any organization, you have projects and you have people, and projects change over a period of time, and each project needs to be filled with the right kind of people. So let's see a demonstration of the cyber talent bridge.
All right, so here is the cyber talent bridge in total. Just want to make sure you can see it. So these are just projects I've been working on. Here is an example.
Want me to go to different projects?
You can see me over there.
Yeah, you can.
Anyway, here's a demonstration one that I've created for this. I have a few different controls I put in here. These are just needed for the actual project that it will need. So this is the AC2.
They can't see. You want to come in control?
They can see you,
I
right?
can see what you show.
Oh, okay.
Sorry. So this is the AC2 control in which might be needed in a specific project. It has its description here, and so each control has different knowledge, skills, abilities, and tasks belonging to it that we get from the framework. So each one has their own given description for each thing. If I click on it, you can see it here. And each one has an importance. The importance kind of tells us how much this might be relied on for a given project that we have. And I can decrease and increase it depending on the project and what I am doing. And so this lets me see what exactly is going on and what exactly I need. So over here on the right, I have a list of people who will, this will match up with who's the most qualified individual to meet my needs in this project. So for example, this person's always at the top, Magdalene Stoll. They show a 44% match with the requirements. I can add or get rid of some requirements needed or whatever I want. So each one, and this shows their certification on their ability to perform a various task, skill, or anything else. So I can kind of see just how well and how comfortable they are in this area. So this also allows me to make changes down here. If I need to go ahead and add a task to a given project or a certain control for the project, I can do that instead and just change it up to whatever I need in order to meet my requirements for whatever I am doing. Turn it back to Deepak. Another one.
Okay, so that was a quick demo for the Cyberturn Bridge, the tool that currently exists. And so, as Jared showed, it matches the 853 controls with the NICE framework. And our job was to understand how the tool currently does that and if we can suggest any improvements. So so there are frameworks and standards, and in the previous presentation from Dr. Kim's team, we saw that there are many of them, and we are currently focused on just two, 853 and the NICE framework. And frameworks and standards, as they are concerned, there are many. And the reason to mention this is that the matching problem that we discussed, it is not a one-time thing. It will continue. The cybersecurity activities will expand. More and more new areas and keywords and understanding will be added. So, and that is one aspect. The other aspect is that there are many different standards, and an organization has to work with quite a few. Right? Just as a quick example, you are a defense contractor, so you have to understand the government terminology, but you also work for other private industries which may not use the defense standards. So that's why many standards exist, and the idea of having to use natural language processing to match the information is going to remain for a long time. So to do the matching, what kind of approach we can take, right? So we want to do the automated mapping, that's clear. So for natural language processing, one can go in two different ways, right? You can do a supervised machine learning, that is, for a given control, what are the various task knowledge skills that should go with it? If you know that, then you can train your model and then work with that model for the new information as it comes by. But we currently don't have that matching because the two standards are different. Any matching that exists is all done manually. And as the standards get revised, which they do, we have to do that whole process manually. So as of today, we have a little data to do supervised machine learning. So in that case, we decided to use unsupervised approach, right, to start with. And we thought the Kmeans clustering would be a good starting point to match controls to TKS. And so next we will discuss Kmeans clustering and other techniques that we used.
As Dr. Pravin was saying, we started with this Kmeans clustering algorithm, which essentially we intended to cluster the task, knowledge, and skills to a specific control. We worked with this method within Python and used the scikit-learn and pandas libraries to implement this. As we were working through testing this method, we manipulated the cluster sizes. From doing that, we found that we were getting different bundles within different task, knowledge, or skills within those clusters, and they were very inconsistent. From there, we experimented with other controls to see if we would get a different outcome. And we were still getting very unstable results from doing that. And finally, we concluded that our data set essentially was just too skewed to implement this clustering algorithm properly. Here's just an example of some of the evaluation that we were doing. Here is a cluster where we use a cluster size of 20, and this was implemented on the knowledges of the TKS. Here we got a lot of knowledges within the cluster group with the AC-2 control for account management that essentially had nothing to do with this topic. And however, few, as you can see, there are a few that were very relevant to that control. After we decided to move on from using this method, we came across the cosine similarity grouping method. This method essentially measures the cosine between angles. And the smaller the distance between these angles, the higher the cosine similarity was. So we tested this out using first essentially a bag of words, which is evaluating the frequency, just more in a basic sense, and then we took it a step further and implemented TF-IDF, which is term frequency and inverse document frequency. In doing this, it essentially prioritize or puts more weight on the frequency of words across documents. So if something was repeated constantly throughout all of a list of tasks, knowledge, or skills, it would have less weight essentially. So prior to doing that, within doing that cosine similarity, we were vectorizing our words. This is essentially assigning a numerical vector for those words so that it can be evaluated within that algorithm. So here is a chart with the MP-8 control for media downgrading. The top two lines that you see here in red and blue, they are a comparison of the TF-IDF skills that were found and count vectorization, which is essentially that bag of words that I was speaking to previously. They are in order of how the algorithm found them ranked to that control. From there, wanted to just compare and see which one of these vectorization methods was best. So here in white, as you can see, these are the skills that both methods had in common, and as well as the differences that they have, and they're color-coded there for you to get a better grasp of. And from this, we really just wanted to manually evaluate the relevance of those groupings that the cosine similarity method was doing. And here at the end, I have tallied the number of relevant skills from doing both methods. And in this instance here with this specific control, the count vectorization turned out to have more relevant skills. Okay, so we wanted to test out that Kmeans clustering again and see if we implemented it with TF-IDF, if we would get a different outcome, as previously what you saw before was implemented with that count vectorization or bag of words. So we essentially here, as this IR-4 control, the cosine similarity had found very high relevance. We were getting and very great results once we ran it on this control. So all of these skills here on the in the middle there, they are all from that cosine similarity grouping, and we wanted to compare and see if those skills would fall within the K-means clustering that took place. As we did that K-means clustering, we got 150 skills, and of that, only 7 of those skills that we found very relevant within the cosine similarity grouping were there, and 11 of them out of the 18 were absent. So it was still not giving us stable data or findings.
Okay, so next we tried running a similarity sequence matcher on our data. I worked with tests and the AC2 control here. You can see down at the bottom, it shows printed off my top 15 results. It shows AC2 as 1 because it's being compared to itself, and then each task after that, the second number on there is showing how similar it is to that AC2 control. This is they're based on the sequence matching. So through this, we found that it was kind of accurate, not great. It wasn't working as great as the cosine similarity sequence, or the cosine similarities, but we didn't find it as accurate as the cosine.
So from all these various experiments, our current conclusion is that the mapping process could be automated, and as of now, the cosine similarity based on TF-IDF vectorization gives to seems most useful result. We tried count vectorization and similarity sequence just to make sure that we are not getting results that we are just out of by chance, right? So we ran on 5 to 8 different controls against and then manually evaluated the results as well to ensure that what we are seeing from the algorithm is actually what we should be getting. So we believe that for some reason which we are not really sure, count vectorization in our sample seems to be close in most of the time with respect to TF-IDF, but as I would like to mention in our future work that we need to expand, what should we do next in this case? So we should definitely expand this to cover more controls than the few that we have tried. We do certainly have ideas about trying different parameters of TF-IDF vectorization, and also try to identify some important term for each control and see if we can give more weightage to it, and that way we can pull out better matching from the task, knowledge, and skill statements. And finally, of course, we need to understand how can we deal with imbalanced document corpus. And the imbalance here is that in case of controls, there is a long description because it describes as activity that an organization must take. But task, knowledge, skills are more atomic in the sense that they are describing one very specific item. So here, what we are trying to find and against what we have is quite a bit imbalanced. So there is definitely room for understanding how can we massage the weightages on the, let's say, target being the control and others being the input side for task, knowledge, skill to get to a better results and consistent results that we can run on a regular basis and even expand beyond the two frameworks that we have tried. So that's what we have tried and understood. And we would like to thank DHS team for this opportunity. And we are ready for any questions. Oh, sorry, and our references are given here, and there is some other information.
Okay, we can open this up for questions from the audience. If people just want to raise their hand or put a question in the chat. You guys did a great job.
Thank you.
Dr. Moon, go ahead. I know you were having mic issues earlier, so we'll give you a minute here. There we go.
Okay, there it is. My question actually dealt with the imbalance that you were talking about. Is it possible that the imbalance is different in different segments of the industry, as in the government writes things a certain way, but that imbalance may not be evident in the commercial sector where they actually do things differently?
That is certainly possible. The imbalance I was mentioning here was that the activity described by the controls, 853 controls, is in lot of details. On the other hand, my task knowledge skills descriptions are very atomic or almost atomic, like they just describe one thing, that knowledge of database management system is necessary, against a deep description of how account management should be done. So that's the imbalance I was describing or alluding to here. But I'm certain that the other imbalance that you mentioned does exist. I mean, I'm not certain, but I can imagine that that imbalance exists, and it may be less in different standards versus what we are currently working with.
Thank you.
Hey, so I wanted to ask about the clustering because, looking at it, it looked like it was clustering a lot of the knowledge groups together. Was that because y'all were only looking at the I guess, knowledge codes, or was that because, maybe it was specifically clustering like knowledge, abilities, and skills together?
Yes, we took it individually, and we're clustering with specifically knowledges, skills, or tasks.
Yeah, sorry, I was just wondering that myself. And then with the TF, IDF, and the count, because we were looking at using both of those vectorizations, and we noticed that TF, IDF gave us what looked to be not more accurate, but better results, right? Was it a similar case for y'all, or what was kind of the deciding factor between TF, IDF, and the count vectorization or the bag of words? Maybe I missed it and didn't get the specifics. Sorry.
Well, we're still currently manipulating that. We firstly manipulated the stop words there, of course, removed punctuation. And so we're still exploring, going through and manipulating some more of that stuff. We have not consistently got that TF-IDF was better, as you saw in that in the presentation we just gave. It hasn't been consistently that way.
Okay.
But parameters, we're still manipulating those parameters, and maybe we'll hit one that does cause us to get that result.
And I'd be interested in comparing stop words with you later, if y'all would be down, because we were having issues with the stop words as well, and so if y'all have any that we might be missing, that'd be great.
Sure.
Max, that's funny that you should say that. One of my questions was, this is kind of for Dr. Kim's team and Dr. Priven's team. You're both at the same university, which is fantastic. And I was just wondering if you saw any, since your projects We're both working with workforce development and the NICE framework. If you saw any, and some of your research was done with similar methodology. If you saw any synergies, I think it would be interesting to see where that might go. Do you have any comments on that?
Oh, I mean, absolutely. We learned quite a bit from their presentation, and would love to more understand. I mean, they the way they did topic modeling, because this would definitely help us.
Yeah, I think I mentioned in my presentation, UNT, we have a specialized kind of program, Cyber Plus Analytic, not a degree but concentration. We are business school, so we are not mainly focused on the developing any machine learning, the text analytic algorithm, that kind of thing. But we are more interested in applying the tools and mechanism and algorithm. So now one of the big trends, as we know, is AI implication. But the text mining, machine learning is an existing kind of the area. But now it's the increase in new knowledge and new tools. So I think this kind of effort we try to build up as a kind of department level. So I think that's kind of synergy we can get. So did I answer your question?
Yes, you answered it. I think I'm wondering if when you write if you think about it, when you write your follow-on funding, that you think about ways that you can leverage each other's work, and kind of make note of that when you write your follow-on funding. If you see the synergies, if
Yeah,
not,
sure.
of course not. But
Yeah. And not only for this case, but the Dr. Previn and I actually worked together to submit already submit one of the proposal for the convergence research, NSF. So we're still waiting for the kind of result. But I think that's kind of effort we may want to have as a team. So yeah, good suggestion. Thank you.
great. Well, and also, something, and I throw this out to all the teams that are on the phone. We'd like to know what you guys are doing. So please, please keep in touch and let us know where your research is going, because it's important to us. If you're presenting at an event or you get published or anything that has to, that is continuous and ongoing, and other items that you're doing. I mean, if you're presenting somewhere and we can watch it or we can promote it, we would be happy to do that. So.
Thanks. And I did not include here, but we certainly want to find a venue for publishing this work, for sure.
Yeah, I think I already expressed thank you to all those mentors and the DHS. I think this is an excellent opportunity for all of us. As a professor, we just working on as a student for the class project, but this is really something. As a researcher, we wanted to work together as a team. But never get a chance with all together, like mentors, a student, and a researcher, professor within short time period, like a 10 week. So it's a challenge, but a really good experience for us. Thank you.
Do you guys want to add anything?
Great job, Anna and Jared. You made us proud.
Okay. Oh, go ahead. I'd like to ask Anna and Jared, just kind of, I know this isn't directly related to the research, but if they could just tell us a little bit about their experience this summer, and kind of what they got out of it. I know in the past, our students have been in person, so this has been very difficult. The last 2 years we've done this for the last 2 summers in virtual, So I'd like to hear a little bit from Anna and Jared about kind of some of the things that they got out of this experience.
Mainly for me, I would have to say pretty much the aspect of gaining experience was pretty much the best part, and being able to actually interact and do this is much different when you're actually doing something versus being within the classroom. So just actually being able to get out and actually do it. Also, I've definitely have learned an extensive amount of technical and interpersonal skills by participating in this, and just a lot of critical thinking and problem solving, because we've definitely been having to test some things out during our research. So that's been really great to actually put into action.
The number one thing I'd say I got out of this is dealing with Python. I'm a data analytics student, and if you don't know, data analytics heavily relies on Python and R and SQL. And before this, I'd never gotten to actually work with Python, so I'm eternally grateful for this, because this has finally given me a step in and just a little bit of confidence into my future and dealing with data and data science. So it's just kind of a comforting thing that I've gone through this time.
Also, it's been great working with all of you guys, and Dr. Provin's been awesome. I've been learning a lot from him, so that as well.
Thank you guys for answering. I know I kind of put you on the spot there, so I really appreciate it.
Right, and we didn't put it in our slide deck, but I don't know if they remember how many times we had to deal with JSON and various CSV, and a file will work on Anna's computer, but we move it on my computer and it won't work because of Windows and Mac and all those issues. So they faced everything with respect to data cleaning. So it was a good time we had together.
Great, thank you guys so much. I don't see any further questions in the chat. I'll give it a second to see if anyone raises their hand. Okay, I think we'll go ahead and take a short break to regroup and give everyone a few more minutes away from their computers. We're going to start again right at 4 Central Time with the next group, and then I'd really appreciate it if some of you guys would stay on the line to hear the next talk. So one more to go, and we're in good shape. So thank you guys so much for your time.
Thank you.
See you later.